Question 18 says graph of 1 by v versus x for a particle under motion is shown in figure where v is velocity and x is position. Acceleration of particle at x equal to 2 meter is minus 4 by n meter per second square. Value of n is. Okay. So first of all, let's write the equation of the straight line that is given to us. So on the vertical axis is 1 by v. So equation is then 1 by v is equal to slope into x. And what is the slope? Slope we can find easily here. We can see that this length is 1 and this length is 1 by 2. The slope is 1 by 2. So 1 by 2x and plus c. The c value of c is 1 by 2. We can see that. It's here. So this is the equation for the straight line that is given to us. Now we have to find its acceleration. So let's differentiate both sides with respect to t. So we get minus 1 by v square dv by dt is equal to 1 by 2 dx by dt, or simply v. Okay, so this gives us that dv by dt is actually equal to minus v cube by 2. Now the value of x is 2. So if I put x equal to 2 in the first equation, we get 1 by v is equal to 1 plus 1 by 2 or 3 by 2, and everything is in SI unit, so it's 3 by 2 meter per second. So the value of v itself is 2 by 3 meter per second, and the acceleration then is minus 1 by 2 and 2 by 3 whole cube. That means it is 8 by 27, or acceleration is then minus 4 by 27 meter per second square. Let's equate this to minus 4 by n meter per second square. So we can see that the value of n is clearly 27. So that means for question 18, answer is 27, right? Let's go to the next question now. Question 19 says a spherical hole of radius r by 2 is removed from a sphere of mass m and radius r as shown. Ratio of gravitational potential at point P and O is x. The value of 15x is. Well, obviously the question is from the topic gravitation, and the concept involved is gravitational potential at a point. Now at point P, the gravitational potential Vp is gravitational potential due to the entire sphere, which is minus g capital M by R minus, now we can remove the contribution due to the removed portion, and contribution of the removed portion was minus g. Mass of the removed portion will be m by 8 because its radius is r by 2, so it's m by 8, and distance from the center of the removed portion to point P will be r plus r by 2, that means 3r by 2. So this is the gravitational potential at point P. Let us simplify the expression further. This 2 will cancel with this 8. So we have this term is then plus gm by 12r. So let's take 12r as the LCM, and then we have here minus 12 plus 1 into gm. So Vp is clearly then minus 11 gm by 12r, right? Now let's look at gravitational potential at point O. So gravitational potential at point O due to the entire sphere, due to the complete sphere, would have been minus 3 gm by 2r, but we have to remove the contribution of the removed part, which is minus g m by 8 into r by 2. Now this is equal to minus 3 gm by 2r plus gm by 4r, and which simplifies to minus 6 gm plus gm, that means minus 5 gm by 4r. And so Vp by Vo, the value will be then minus 11 by 12 divided by minus 5 by 4, and on simplification this is 11 by 15, right? So this is the value of x, and value of 15x then will be clearly 11. So that means for question 19, the answer is 11. Let's go to the last question of this test now. So now we are at the last question, the question number 22, which says two pistons having low thermal conductivity divide an adiabatic container into 3 equal parts, 1, 2 and 3, having initial pressure as shown and the same temperature T0 equal to 300 Kelvin. Now the pistons are released, and after a long time, piston separating 1 and 2 gets displaced by x centimeter. Find value of 3x. So this is the arrangement. We have an adiabatic container which has 3 parts of equal lengths. The temperature everywhere is 300 Kelvin. The pressures are different initially. The pressure is 3P naught, and on the portion on in fact parts 1 and 3, pressure is P naught, and the pistons are released, and after a long time the pistons get displaced by x centimeter. That's given in the question. We have to find the value of 3x. Well, we can apply the concepts of thermodynamics here. Now see, the volume of the gases is fixed, right? So individual gases can change their volume, but overall the total volume is fixed, which means that the work done by the system is going to be 0. Okay. So the one important point here is that work done is 0. We can see that delta Q is also 0 because no heat is being supplied from outside. So which also means that by applying the first law, delta U is 0. So the temperature is going to be same everywhere. That means the temperature will also be 300 Kelvin finally. Now let's say that again by symmetry we can say that each of these partitions will move the same distance x. So this is moving x distance this way and this is moving x distance this way. Finally pressure in all 3 compartments will be equal, right? That's when the pistons will stop moving. So we have seen that delta U is 0, so temperature is not changing. The conditions are isothermal conditions. So if I apply PV, P1 V1 equal to P2 V2 because temperature is constant, we have the equation now P naught into, if the total length is L, each part had length L by 3. So area of cross section into L by 3, that was the pressure into volume initially of the first part. And this is finally equal to the final pressure into A, and the length now is L by 3 minus x. Okay, so we have one equation here. Let's apply the same equation for second partition, and for the second partition initial pressure was 3P naught, again length was L by 3, area of cross section is same. Now its pressure also is P, so it's P into A. Now the length of this part will become L by 3 plus 2x, x on this side and x on this side. Total increase in length is 2x. So this is what it is. Now we can divide the two equations to eliminate P, and if we do that, we will divide equation 2 by equation 1. We get 3 is equal to L by 3 plus 2x divided by L by 3 minus x. Let's cross multiply. We get L minus 3x is equal to L by 3 plus 2x, or 5x is equal to 2L by 3, and that means the value of x is 2L by 15. And if we put the value of L, which is 90 centimeter, this is 2 into 90 by 15 centimeter, which is 12 centimeter, right? And the value of 3x then is 36 centimeter. So that means the value of 3x is 36. Well, it's 3x centimeter here. So the answer to question 20 is 36. Well students, with that we come to the close of this quick solution. Hope you found the solutions useful. I wish you all the very best. Take care. Bye.